We're going to consider the solutions to x squared equals -1. Now, when we solve x squared equals -1, we know that we need to undo the square by taking the square root. So I'm going to start with that by taking the square root of both sides. And when I take the square root of both sides, that's going to give me x equals the square root of -1. Well, the square root of -1, we would also have maybe a plus or minus here, but right now that this plus or minus is not significant, we're going to look at the square root of -1 and discuss what is it that we multiply by itself that is -1. Well, there's no real number that we can multiply by itself to be a negative. Any number times itself is positive. So before we were told, maybe in an Algebra 1 class, to solve this. And when we solve this, we get a value that we call not real. Some might have learned to say no solution. Well, there's definitely a solution. That solution, though, is imaginary. So we have an imaginary unit, I, that is equal to the square root of -1. So that whenever we have the square root of a -1, we can replace it with I. If I is equal to the square root of -1, then we can say that I squared is equal to -1. These are two facts that we are going to base everything we do hereafter upon. So let's get started. We have the square root of -25. The square root of -25 is not a real number. So we're going to take that negative out, and the way that we take that negative out is through taking out an I. So we rewrite this as I times the square root of 25. Another way to think of this is by making the square root of -25 the square root of -1 times 25. And we know that when we do this, we can separate out those two factors and find the square root of each factor. The square root of -1 is I times the square root of 25, which is what I have in red. I times 5 is the same thing as 5i. So we typically write the I as we would a variable. It follows the numerical coefficient. You're going to see me do this work the way I've done it in red here. So you're going to see me take out the negative. And when I take out the negative, it's the same thing as taking out an I. So this works when we have the square root of a negative number. So that's a square root of a negative number. Okay, let's try another one. The square root of -196. The square root of -196 is I. We take out that negative, that gives us an I times the square root of 196. And the square root of 196 is 14. 14 times I is going to be rewritten 14i. Now, we can have imaginary numbers when we do not have perfect squares in the radicand. So when that happens, we are still going to go through the process of taking out the imaginary unit I. So we have I times the square root of positive 24 now. Then I'm going to come off to the side and I'm going to break down 24, 2 and 12, 2 and 6, 2 and 3. So we have a pair of 2's. One of those 2's will come to the outside, and 2 times 3 is left over, remaining on the inside. So we have 2 on the outside and 2 times 3, which is 6, on the inside of the radical. Now again, let me show you why this works. I times the square root of 4 times the square root of 6. The square root of 4 times the square root of 6 is the same thing as the square root of 24. But if we break it up this way, we have a 2. So this right here is a 2. 2 times I times the square root of 6, which is what we have right here. Now, one thing to note, -1 is the only number, I'm going to use a shortcut there for number, that is removed from the radicand without a pair. And that -1 becomes I, because the square root of -1 is equal to I.